devices here. Okay. Picture. Yay. All right. Being a successful developer means figuring out how to use a keynote presentation on the fly. You may also want to be trying to level up your career. You want to teach others. You want to write, apps that surprise and delight people. Heck, you might even want to start a podcast on iOS development. So how do you get to that position? How do you get there? So today's talk is a couple of things. This, as you mentioned earlier, this is the hashtag for the conference. It's also the hashtag for Taylor Swift's conference this summer, so there's a little confusion. This talk has been in progress for a few years, yeah, so anyway, we'll carry on. So as you mentioned before, here's the 411 on me. He gave away most of the stuff here. My Twitter account is Tim Mitra, Timmitra. Morning Just Code Podcast, Spotcast Podcast, which is about centers around discovery and a new Picard series. But we also talk about all kinds of other sci-fi, comics, books, anime, that kind of stuff. And roundabout. And I also write tech blogs for raywunderlich.com. I've been doing tech writing for about 20 years. And 5 years ago, I joined raywunderlich.com, done a few articles and tutorials and video courses. So, and I brought some books to give away. Maybe if I don't have time today, I'll give them away and we'll put them into the raffle. Yeah, so this is sort of the agenda for today, starting with your intent and your impact, why you're doing what you do, how we learn, how we actually learn, which is kind of an interesting thing. And I'm going to go into a couple of tangents on that sort of section using brain science to teach you how to hack your own brain. And how we're involved in our communities, how we give back, how we mentor, how we can get mentors, and what really matters in what we do. So the More Than Just Code podcast, we started this a few years ago, 5 years ago actually. We just had our 5th anniversary this weekend. And it's basically started out as a 3 or 4 senior developers kind of talking about Apple and iOS and the challenges we have in running a business and all kinds of different things, working in enterprise, working with tools and that kind of stuff. So it's quite popular. If you search for Swift development or iOS development in the App Store and podcasts, we come up #1 worldwide. It hasn't made us any money, but at least we're happy that way. And if you wanted to start today to binge it, you're looking at 20,000 minutes of podcasting, so that will take you 337 hours or just over 2 weeks. So feel free to binge that one. So the important thing is start with why. It was a book by Simon Sinek called Start With Why, and he examines successful businesses and business concepts and marketing. You'll probably see a lot of it you can look for him on LinkedIn. Everybody links his talks on there. But the point of the Start With Why is that people don't actually buy the products that you make. They buy the reason you make them. So in the case of Apple, which is one of his examples, people don't buy, they make computers, they make phones, they make, servers and that kind of stuff, and they write software. But people buy the experience that Apple brings to you. And that's what comes down to your intention. And he repeats this throughout the book, people don't buy what you do, they buy why you do it. So intention is a big part of what we do. And for me, I was interested in engineering at the end of high school, but I was a better artist, and somebody convinced me to go into art. So I changed my choice and went into art and down that path. And I got back into it through the Mac. And getting a Mac for the first time, realized that I felt there was more I could do with it. And that's kind of led me down the development path. And one of the things I studied in university as in the art class was about the role of the artist in society. We sort of look at what goes on in society. We make statements about what we think we see, how society works and that kind of stuff. And that's very similar to writing code. And we'll talk a bit about the art and science of code a bit as well. So this is kind of where we're at in the current state of technology and art and our daily lives. And communication is a huge part of what we do. But I just want to point out, this is not communication, right? This is, part of our coding desire desire of coders is to put together things that bring pleasure to people's lives, makes things easier, makes choices easier. And we think logically, and we break things down into smaller parts. I just love this slide, which is always in all my talks. But anyway. And one of my co-hosts on the More Than Just Code podcast, we were talking about this a few years ago. And, we were talking about intention. And, Apple, like I said, wants us to surprise and delight our customers. And the question is, why are we doing what we do? Why do we make the apps that we're making? So whether you're building the next Flappy Bird, or you want to help, people with disabilities, or you want to write the next, Touch Bistro app, what are you doing? Or as Jaime says, how am I making a difference in people's lives? So my goal as an artist, as a tech pundit, and as a person who brings solutions to people, a solutions developer, my ultimate goal in life is to make a dent in the universe, right? And I told a story when I gave this talk at Taco a few months ago of Jamie Newberry. She was the CEO of the Martian Craft, I think so. One of those large iOS organizations. And she basically looked at where she was in her life and what she'd been doing. She had a little daughter and a new husband and that kind of stuff. And she thought, well, I don't want to have on my epitaph that I was the CEO of a major iOS company that made lots of money. So she gave that all up and followed her passion and went into producing dresses for kids. And it turns out you worked the technology into it. So now there's an iOS app and a whole lot of other stuff. But so she kind of imagined what it was like, what her legacy is going to be. And that's kind of sort of where I come from it, right? And Apple, as I said earlier, is not about the phone. It's not about the features. It's not about, how many mega hit flips and mega flops and whatever. It's all about the experience that you get using their products. So, as I mentioned before, one of the things I do is I write tech podcasts for Ray Wenderlich. And he's got this wish list. So, it's not just, Apple rolls out Swift UI and so the team over at Ray Wenderlich runs over and starts writing Swift UI. That does happen. That's true. But there's a big wish list that he's got. And so I was looking at the wish list one day looking for an article to write. And I saw this, article. It wasn't exactly how to keep learning after 50, but I thought, I'm over 50. I could probably write this article. I know a lot of older senior developers. We can get their input and put together a really compelling piece on how it is that we manage to keep learning. Because the assumption is, as the saying says, you can't teach an old dog new tricks. Well, it turns out that that's actually not true. It's a myth. That theory of the fact that your brain develops to a certain point, and then around puberty, and then then you just start losing brain cells. We all joke about drinking and smoking and all that kind of stuff, but the reality is that a friend of mine actually sent me one of the people I was interviewing for the piece sent me a link to a video that he saw on YouTube, and he's a banjo maker. He makes banjos. He plays music. He's a blues guy. We went to high school and university together. And he sent me this thing on neuroplasticity. And it was written by a guy named Dr. Josh Turknett, who's a neurologist, a musician, a neuroplastician. And he's also the founder of BrainJo. And BrainJo's whole idea is that using neuroplasticity, you can basically teach yourself to do just about anything if you follow the sort of the principles and understand how it is your actual brain forms memories and knowledge and that kind of stuff. So neuroplasticity is the sort of first part of learning how to hack your learning. So the thing about the brain is that it actually has a whole plastic mapping that it does, or cortical remapping they call it. And you talk about it in context of recovery, like if people are having strokes or brain injuries, how does the brain adapt itself to do this? We all think that the brain's compartmentalized and has certain roles, but the reality is that your brain, the gray matter in your brain, can actually grow and it can get better at things depending on how you practice and what kind of stuff like that. And the synapses that form when you think about things, when you work with your brain, they can grow and they can shrink. Like if you stop practicing something, that'll eventually whittle away and you won't remember how to do it. But so the trick he had in this video on BrainJo was that using neuroplasticity and the way the brain forms thoughts and structures, he found it's best if you practice in small spurts, like 40-minute spurts at a time, as opposed to sitting down with a book, like the Ray Wenderlich book, like I've got down here, and reading from front to back, and now I'm an expert in Swift UI. It doesn't work that way. The reality is that you get these initial feeling that you're accomplishing something, but if you walk away for 2 days, those memories are gone. So that's what the whole thing about practice makes perfect and all that kind of those things. That's true, but the reason why is because of the way the brain works. Another piece I saw was by Dr. Laura Boyd, who's a studies strokes in recovery patients in UBC, and she talks about how the brain actually forms memories. And one of the things first thing the brain does is it forms chemical structures or uses chemical signaling between your neurons as parts of your brain, the cells in your brain, to form immediate memories. Like what kind of juice did you just pick from the breakfast bar back there? Who did you meet just now? What was their name? And in like an hour, you won't remember their name. But the reason why is because these memories that you form with these chemical bonds seem to be pretty clear and pretty strong, but after time they dissipate because they're just temporary there. The brain just makes them for a short purpose. And so that's what short-term memory is all about, right? But with repeated practice, you can build structures in your brain. So the brain will start to actually hardwire a connection and make a memory like more solid. And this is where I talk about making the hacking your brain comes from. You can, through repetitive techniques, you can start to form memories and make things last longer. So in the case of and they've looked at the brain structure in people who speak Braille, for instance. The part where their motor skills in their hands, that part of the brain is much more developed. Or in the case of taxi drivers in London who have to memorize the city of London before they can get their license, that part of the brain that handles geolocation in their head, I forgot the term for it, but their part of their brain gets more developed. And if of course, if you're right-handed, the left side of your brain, which manages your dominant hand, gets bigger as over time. So, and what happens after a while is these little structures that you build you can start to use more than one part of your brain, and sort of like what we do with coding in a sense. You form functional changes in your brain, and so you start to build behaviors with these memories that you've formed. And so, like for instance, if you take driving, for example. You can, you first learn all the little bits and pieces to drive, and then some of you drove here today. You left your house and you got here, and I probably can guess you can't remember exactly all the steps you went through to get here, but because your brain has formed this sort of muscle memory to be able to do that. One of the examples I like to use in this particular part of the talk is on Wayne Gretzky, but I'm updating it for the times because now we have Kawhi Leonard as our example. And he, very similar to Wayne Gretzky, who would get to the practice before anybody else, and he would be the last one to leave the practice. He'd go out with a bucket of balls, and he would basically shoot the same shot over and over again. So he would stand in the corner of the court, and he would shoot a three-point shot repeatedly for every practice he went to. And you can see the payoff of that. It was in the semifinals, the seventh game of the semifinals. You remember he did that shot at the buzzer, right? And that's because he had formed in his mind the behavior, or in his brain, his behavior, to have that muscle memory, to remember how much velocity to put on that ball, how to shoot it, how to get it, how to land it. And we all, we basically are world champions because of that behavior, right? And that practice. So one of the things that this is James Dempsey here on the left, and he has a band called James Dempsey and the Breakpoints. And he appears at places, at conferences like WWDC and RW DevCon. And he has this band called the Breakpoints. And I'm one of the I call myself a conditional breakpoint because I play with them occasionally, right? So, and I don't like to travel into the States with my guitars because I'm always afraid that the airport's going to trash them, and or the handlers. But so I take my ukulele, and I'm not a really ukulele player. I've been playing guitar and singing in a band for about 20 years now. And again, same sort of thing. I didn't realize at the time. Now that I've been 2 years into this understanding of neuroplasticity, I've started to apply those principles to learning my Swift UI and also playing with James Dempsey. So he'll send me an MP3. This year he had a new song for WWDC, which I'd never heard before. So he sent me that, sent me the chord charts. I get my ukulele out. I remember the chord positions because they're really weird. They're not the same as guitar. And so by the time, and I practiced a little bit every night, and, to work on just the main part of the song, and then I'd work on the bridge by itself, as opposed to trying to learn the song end to end. Work on those small little pieces and then put them together. So by the time I hit the stage, it looked like I was a professional ukulele player who'd been playing the song for many, many years, even though I'd learned it a week before. Yeah, and I use that currently now to learn Swift UI and Combine as well. And just one thing, just remember, don't think about the pink elephant. So how many of you guys are thinking about pink elephants? Okay. And just, we like to do this on our podcast all the time. We like to say, this is for entertainment purposes only. I am not a neuroplastician. I'm not a neurosurgeon. I play one on podcast. And so, yeah, this is just for entertainment purposes only. It turns out actually the way neuroplasticity does actually work is a variable. We all will learn at different rates and different capabilities. So take that with a grain of salt. Which brings me to community. So one of the things about community is that we're all participating, whether you're on a small team or a large team. We have peer reviews and we learn from each other. Hopefully, we come to conferences, go to tech talks, that kind of thing. And another part of what our community part is our giving back. Like my giving this talk right now, my starting a podcast for nothing and just putting it out there for people to listen, and mentoring and wanting to teach and help other people solve their problems and get better at what they do. So, as I said before, one of the things about coders is we look at the world in terms of inefficiencies, and we try to solve these problems and make things better. Software has accelerated our inefficiencies. You can order a pizza, you can get a cab now, you can, get a ride from somewhere as opposed to using a cab, using Uber and that kind of stuff, right? And culture is speeding up in a lot of different ways, and we're sort of losing some of our appreciation for how to slow things down a bit. Like Twitter as an example, started out as a place where you could put up a bunch of statements. I'm doing this now I'm doing this, And then people decided they wanted to respond, and Twitter had to sort of, Twitter changed. They started the at handle so you could respond to the person who made the tweet. And that kind of, technology kind of moves forward a bit. But coming back to code reviews, or peer reviews as they're probably called, I had a particularly bad code review about a year ago, and I thought of a future conference talk, like how not to be a dick giving a code review, right? And my friend Alexa, who is in San Francisco, a super smart guy, he basically replied back to me, it would actually be better talk if you said how not to seem like a dick doing a code review. The reality is we're not taught how to talk. We're taught how to drive. There's a manual. You can get a manual. You can learn how to drive and that kind of stuff. But there's no, coming back to neuroplasticity, when babies are learning to talk, they start by making gurgling sounds, and they start to form different sounds, and they listen to the sounds of their parents, and they try to mimic those sounds to the point where they actually start to form words, and the parents' brains explode, and we eventually learn how to form sentences and talk and that kind of stuff. But there's no real sort of manual on how to properly communicate with each other, which is really important when it comes to code reviews, for instance. But taking a step into the driving thing for a minute, you get this manual, you read the manual, go into a classroom, learn the rules of the road, you practice, you go out for actual practical driving tests or driving lessons, and you learn the different parts of driving to the point where you get so competent that you can actually go and take a test and pass, and then we evaluate you and you're good to drive, right? But there's nothing like that for communication. There's no sort of playbook. There are rules of diction and etiquette and that kind of stuff, but we tend to not pay attention to them. And there are classes, of course, you can go take for effective training. But coming back to my art experience, similar to a code review, we had this thing called critique, where whether it was as a student or as a working artist, because artists tend to work together in groups like TACO or NS Coder. You take an assignment away, you go and work on it for a bit. After a week or so, you come back, you hang your work on the wall, literally, and you talk about what you did, what your intention was, what you were trying to achieve, why you put the paint on the canvas the way you did. And then you open it up to the rest of the people in the room, and they give you critique on what they think about what you did and how you applied the paint. And it's just like a code review in a sense. I used to hate these things. And we'll talk about why I hated them in a minute, and why that part of my brain did that. But yeah, this is so much like code reviews is not funny. So this little almond-shaped thing in the middle of my brain there is, this is a scan I made of my head last night, but not really. But that little guy is called the amygdala, and that is one of the most primal parts of our brain. And where you want to form logic and figure out that problem, work on those algorithms, solve that, initial thing, is in the neocortex. But the amygdala is 100 times faster than your neocortex. So you're going to get a reaction right away. So the question is, why do we panic, when situations come up? Why do we worry about hitting that, create code PR button in our tools? Because we're concerned about the kind of reaction we're going to get back. And so because the amygdala manages emotional responses, it's part of our defense mechanism. That's what we see a snake on the ground. Do we run? Do we, freak out? Do we freeze? Do we fight it? So fight, freeze, and what's the other one? And this is where imposter syndrome comes from. Like, am I really a good enough coder? Am I really doing all these kind of sort of, base emotions come from this part of the brain. And when you realize that, you can teach yourself to stop and think about it for a minute, maybe drink some water, Don't reply to that tweet right away. The problem with modern technology, the way it works now, is we use HipChat, we use Slack, we use Twitter, we use Stack Overflow, and everything in black and white. And in black and white, you cannot read intention. You can't tell if the person writing the comment is being friendly or being accusatory or whatever. And how you react to that is kind of sort of on you. The trick is that and as it says here, a statement triggers the amygdala. That's wrong. You should never do it this way. You're incompetent. You shouldn't even be working here. All these kind of things will trigger a reaction in your amygdala. What you really want to do is as code reviewers, you want to pose questions back to them, because the questions trigger or engages the neocortex. Should you have done it that way? Have you considered using Swift 5's new result piece for success and failure? Have you, maybe you could have done it, have you considered doing some other things? So that's sort of what you want to do when you're writing code review or responding to a code review. Think about how you're doing that. So, there's the picture of the neocortex. So imagine this guy, right? Imagine the stress he's under right now, right? So intention and impact play a huge part in our thing. So, there's two sides to it too. You're also the guy writing the requests. You want to make sure that you add comments into your code, describe what you're trying to do, describe why you think you did it this way, and why you think it's important is the best way to do it. Because the purpose of a code review is not to judge each other as we tend to think it is. It's about reducing bugs in our code, right? It's about validating that we met the requirements of the task. And it's also an opportunity to learn from our peers, to learn from our others. And also, if you're working on a code base, a huge code base, maybe to get familiar with the code base, right? So you want to do things in your coding teams. You want to have, a coding standard. You want to have some sort of get together and agree on what kind of conventions you're going to use in your code. You may want to use linter tools to sort of, parse through your code and make sure you've followed, white space rules or whatever it is, length of line, whatever you decide to come up with. You want to have cohesion. You want to engage. You want to encourage dialogue about the code that you're working on. And the point is, you want to help each other up, not put each other down. Right? I call this an anonymous tweet because I saw it about 6 months ago. I liked it on Twitter. I thought I could go back and find it, but I can't find it. So it's anonymous for now. When I figure out who actually tweeted this, I'll give them credit. So you want to make good code and PRs. And they're discussions, they're not dictations, So, and back to Simon Sinek, the guy who wrote the books, Start With Why, a team is about trust. You want to be able to trust the people you're working with. You want to collaborate. One of the things I'd say to our junior programmers, and one of them sitting in the audience over here, is, if you don't understand what's happening in the PR, if you don't understand the comments you're getting, contact the other person. Hit them up on Slack, get up, make an appointment, go talk to them, bring your computer with you and sit down and work side by side, figure out what it is about your code or the way you're doing it that they don't understand. If you don't understand, I mean, stick your hand up and ask for help. There's nothing wrong with that. And another thing about the brain is it has a tendency to steer towards negativity. We have a negativity bias. And because the brain actually tends to remember negative inputs rather than positive ones. And again, that's a defense mechanism in the brain. Like we need to deal with that snake, whether we're going to run or fight it. And if you're writing that review, be considerate of the type of language you're using and how you're putting your words together so that you don't sound, you're not putting down the other developer, or you're not accusing them of being incompetent or whatever. You want to try and help them get better, to make your team better ultimately. And as a mentor, you want to basically make your fellow coders feel good about their stuff, right? You want to provide supportive code review culture. You want to give constructive and actionable feedback, right? You want to, it doesn't take much like to see a developer banging his head against the wall. And if you can just come along and, lend them a hand, that's what the whole role of mentorship's about. So, we're all craftspersons. I changed this word last night because there is no actual gender non-specific word for this, but you can imagine what the word was before. Yeah, coding is part science, it's part engineering, and it's part art. As an artist, I can tell you that it very much feels the same way when I write code as I do when I work on a painting or something like that. So you want to make sure that our code is correct, we want to make sure that it's simple, and we want to make sure it's efficient, and we want to do that together as a team. And it's not a new concept, right? I mean, this is a quote from Confucius, an ancient Chinese guy. Hope I didn't say that wrong. But and coming back to the neuroplasticity part of it, coming back to what Laura Boyd was saying, and there's a TED talk, I'll give a link to it after this. Basically, behavior is the key to learning, but it can be positive and negative, right? You want to have those sort of repeated behaviors. The whole thing they talk about habits can be formed in 21 days. That's part of that neuroscience thing that we're talking about, right? And one thing interesting she says in her talk, and I'm going to say it to you now, is that your brain is not going to be the same today when you leave as it was when you came in. Not just because of my talk, but for all the other talks you're going to get later on today. So to quote her directly, you and your plastic brain are constantly being shaped by the world around you. Everything you do and everything you encounter is changing your brain. So just a little side note here. So I said before I'm using this to learn Swift UI and Combine as well. And I don't know if has anybody here loaded up Catalina and started working with Xcode. Well, here's a couple of tips for those of you who haven't. If you're concerned about the amount of space on your hard drive, I've got to throw some code in here, right? But if you're concerned about the amount of space on your hard drive, we're all working with APFS now, which basically means you can have another volume, and there's scalable volumes. So you can, without having to reformat your hard drive, you can go into Disk Tools and you can make Catalina volume. I think I have a screenshot here. And you can install Catalina on that. And in new structure, in the way that Catalina separates the hard drive out now, you see my Macintosh hard drive there, it says Mac HD and Mac HD data. Your live data goes there. The HD part is a read-only partition that Apple's putting the system software in now. So you can basically have the Catalina drive in there. And then you can use a trick in the users and groups to go in and change your home folder back to your own original hard drive, your HD drive, your Mac HD. So, and that way you can have the same home folder whether you're running Mojave or Catalina. So you can go in and try and play around with Catalina a bit without wrecking your whole system and ruining your life. If you really don't want to go down that path, another thing you can do, and again, this is another little micro-learning thing I learned from people like Paul Hudson, who we'll hear later, and Mohammed Azam, is you can run Swift UI in a playground on Mojave, right? So you just have to import playground support and import Swift UI. And where the rubber meets the road is this content view, which is what contains the UI, Swift UI view. And as long as you have a UI hosting controller set up, and which you can see down here, and you pass in the content view that you're created above, then you can basically do previews. It's not live, but you hit the little play button on the bottom of the playground and it'll render the view that you want. So that's another little trick for Swift UI. And now, just for perspective, in terms of all of this brain science stuff and where we are and making a dent in the universe, this is a picture taken by Cassini in 2013, I think. Yes, July 2013. And the little dot there, here, I'll help you with an arrow. That little dot right there is where we are. So in the grand scheme of things, this is where we are in this is everything that matters right there. Here's some links to some of the things I talked about in the show. I didn't talk about this 10 tips. We talked about this on the podcast on the weekend. Jaime Lopez's pick was 10 tips for reviewing code that you don't like. And it's tips to help you. These slides will be available later. But help you deal with code that you just want to start screaming about, right? Or whatever. That's your amygdala, again, if you start screaming. And I have a video now, but I don't know if we can get the video going. Maybe I'll just play the video from my Mac. Because I like to, I went to a couple of talks with Apple, and they were telling me, one of the things I had to do in the interview process is I had to do a presentation, and they, see, how can I make this big? Hopefully this will work. Oh, sorry, I'm on the wrong screen. One sec. Come on. If I talk nice to it, maybe it'll do it. Oh, there we go. Okay, cool. Oh, maybe it won't run. Oh, well, I guess we'll have to skip that. Sorry about that. It'll be in the deck. So, thank you.